All right. Good afternoon. I'm Tony Mormino, and welcome to the Engineers HVAC Podcast Live Edition. We are going to talk about grow room HVAC today, and I have two expert grow room experts, equipment selection, controls experts, support experts, Chris Adams, PE. Chris, how are you doing today?
I'm doing very well. Thank you, Tony.
Thank you for taking the time out and joining us today. And the one and only Kirk Patton. How are you, Kirk?
I'm doing wonderful, Tony. Thanks again for today.
Thank you. And thank you for my amazing Insight Controls hat.
Absolutely.
I appreciate you. Tom, thanks for joining us today. So this is a live edition of the podcast. So you're going to hear a lot of ums, ahs, some coughs like you just heard, and that's okay. We're going to try and talk about, we're going to talk about grow room HVAC. And I use the word grow room, but really what we're talking about is any type of commercial indoor agriculture facility. I use the term grow room because everybody's kind of common. They think about, indoor cannabis grows when we talk about
lettuce and tomato, rooms. Tony. Lettuce and tomato.
Lettuce and tomato. That's right. Medicinal purposes only. That's for sure. So, yeah. So any type of indoor commercial grow room is kind of what we're going to talk about today, excluding greenhouses. I don't know. When I think of inside commercial grow rooms, I don't even think of greenhouses. Is that accurate?
So, it's interesting. We actually have a greenhouse in Minnesota.
We do
indoor agricultural for. We do. It's the only one we ever had. It was really kind of cool to visit, especially on that large of a scale, right? I think greenhouse. I think something in my backyard, 20 by 30, right? And that is not the case there. And the temperature fluctuations in that place was unbelievable.
Right. And we actually have one of the largest greenhouses in the Carolinas, probably about 10 miles from the office.
Yeah. Oh my gosh, really?
They do a tremendous amount of plants, but the conditioning you do in a greenhouse are very different than what we're talking about as a grow room.
Okay. Well, I'm glad we're talking. That could be the next podcast. So I'm going to write it down right here. We'll get you on the Keller. We'll talk about grow room. We'll talk about greenhouses, growing in greenhouses. So yeah. So when we talk about commercial grow rooms, if you're watching this, we're talking about, when I first started getting familiar with these facilities, I'm thinking of, a couple dudes in a warehouse. They got a few air conditioners. They're skateboarding around. They're having fun. These are actually very serious businesses, very expensive to own, to operate, to conceive. And it's very serious. Like there's a lot of serious stuff going on there, and a small mistake in the design of the HVAC, the controls of the HVAC, selecting the wrong equipment can cost some big money. And we've seen that because we've gone in and provided retrofits for applications that don't have the right type of equipment. So let's talk about this. So what I want people to do, if you're an engineer or contractor and you're not familiar with these facilities, is to leave here understanding these are way different than the typical HVAC type projects we typically get involved in, right? So I've been in the industry for 25 years. If you work, thank you about that. Thank you for the comment. If you work in commercial HVAC and you're doing schools or you're doing office spaces, you're doing libraries, whatever, universities, this is totally different. Like all the rules of thumb, all the design ideas you have, concepts kind of go out the window. So don't air condition these like an office space. Chris, what are your thoughts on that?
Yeah, it's highly different than an office space. I mean, you think about the interesting aspects of this is that why are we going to indoor grow to start with? And most of it is because Mother Nature is kind of nasty at times because she'll swing the temperatures all over the place and it'll affect your crop. So therefore, as you start to truly control the environment, you can maximize what they call in the yield of the product. So they don't have any bad crops if you actually control that. And it's come so much so that you talked about it's extremely expensive to maintain, to put together, but it pays for itself very quickly because of the fact that you get that crop out at a higher quality as well as even faster at times because you can force different growth cycles.
Kirk, yield. Talk about yield, the importance of hitting that right temperature and humidity, as Chris was saying.
Well, I mean, at the end of the day, yields their dollars, right? I mean,
Mhm.
if you're not controlling the environment correctly and you're affecting the yield, you're effectively hitting the product either in a quantity state or a quality state, or even worse, sometimes both, right? You're only getting 80% of the product you should have, and it's an inferior product than what you were supposed to produce. I mean, some of these rooms, you're not talking $10,000 or $20,000 in a room. You're talking major money in some of these larger grow facilities. I mean, one of these rooms that you're picturing, it's over $1 million in product. If you affect the yield
Wow.
even by 5%, that's a significant impact, right?
Mhm.
So if the entire environment's not being controlled, or you're lengthening the growth cycle, or you're shortening the growth cycle, you really start to affect the product in itself. And somebody like me who understands the mechanics and the control side, I don't see it like they do, but a lot of these growers, they can look at their plants and tell if they're happy or sad. And well, while that's not
Mhm.
a common thing I would see, it's important to them.
So you brought up a good point with the yield. When I think of yield, I just think in terms of quantity, but you're talking about quality too. Like if we don't
Quality
hit
as
that
well.
right temperature and humidity at the end, and if you're not familiar with grow rooms at all, when it starts small, it needs a different temperature and humidity than near the end of the grow. There's all kinds of terms that I don't know because I'm not an expert on it, but you have to be able to change the temperature and humidity set point in the space as the plant goes through its life
Correct.
cycles. Is that correct?
Correct. Yeah. Everything from when it starts as a seedling to where it's getting ready for harvest. There are some growers that it almost changes on a 6-day interval. And if you think about that, when we start looking at a 90 to 120-day life cycle, if you're altering temperature and humidity every 6 days, you have to have a fairly broad range on how it's handled. And then when you're controlling that way, that's, these guys are a testament to what they produce, right? So they know, again, that quality and that quantity they should be producing based on their numbers and their years of experience.
And you end up at the same time also doing day versus night, which
Correct.
day versus night does not mean our day versus night. It means the indoor day versus night, because you'll typically do a day cycle and a night cycle and then flip flop it in a different room at the same time every 12 hours to keep your power consumption down.
Yeah, so let's talk about that, because I think that's one of the here's what I understand the challenges are. Well, there's a lot of challenges, right? First of all, they're plants, they're not people. So there's a lot of water going on in the space. There's the sensible load of the lights, which are required to grow the plant. And then, like Chris was talking about, then you take all that sensible load away, right? So at night, which means lights off, I understand, you have a whole different set of conditions to deal with in terms of the air conditioning, the dehumidification, the reheat. And then you might have one grower who likes it one way and another grower who likes it another way. So they could be two rooms next to each other. Well, it's almost like different chefs like using different ingredients or whatever. That's probably a pretty lame metaphor, but you have, even though it's the same room, you've got growers that like it in a particular way. So, what happens in HVAC equipment, Chris, when we take away all that sensible load in terms of controlling temperature and humidity? What is the challenge there?
Well, the challenge then is you have to do the dehumidification, which means you've got to get the dew point target.
Mm-hmm.
But at the same time, you still don't want to get cold. So you also have a reheat target that you've got to come back with. So you got to get the moisture out while keeping and maintaining heat. And so when you think about sensible heat ratios, you can come up with negative sensible heat ratios at times, because you've got indoor cooling on its own in some of the water, but then you're still having to dehumidify because it's giving off more moisture than is really going to come out. So you almost have to truly dehumidify while you're also providing heat, because you have both challenges at the same time.
Which is not an easy thing. Standard equipment just can't do this, right? Like, we've seen it a million times. We sell standard equipment. There's great applications for standard equipment. This is not one of them. In our experience, maybe people have figured it out, but a
lot of people have tried standard equipment, and they do that all the time. They say, well, I'll just buy a whole bunch of residential systems and try and put them in. And they realize very quickly they're not getting to where they want to get to. And so that's really the tough piece about it, is that you can't just go in with the standard, what you thought you knew on a grow room.
Right. Yeah. So, the takeaway I hope people get from this is, we're not the only ones who do grow rooms, but make sure who you're working with has a resume of experience in these rooms, because even if you have the right equipment, the experience of how to control it, is extremely important. And I think we'll talk about that in a minute. But we did have a question from Tom Leck. I hope I'm saying your name right there, Tom. What do you feel about grows who do not invest in redundant backup humidity control and or temperature control? So redundancy in general, what are your thoughts, Kirk?
So what I will say, in the past probably 6 or 9 months, we've seen most of the growers we're dealing with now, and again, our breadth is a little bit more than where I sit today. They're starting to look at redundancy for the humidity control side, adding up backup and adding additional capacity and designs, which we weren't seeing 5 years ago, right? Mm-hmm. They were just kind of trusting the system as it was. And we've seen multiple different designs. So I do believe that that's getting more and more popular. The real question is going to be cost, right? When you start adding redundancy, and as you put it, Tony, specialized systems, as Chris pointed out, it's not just a sensible machine, it's a latent machine. We have high moisture loads we have to deal with, right? This is not cheap equipment either, right? But they're not cheap rooms. So when you start adding redundancy and increasing, you're driving costs up. Should it be there? Absolutely. I believe in any mission critical environment, you should be looking at redundancy. This goes beyond grow rooms and indoor agricultural. But if you're mission critical, if you're something that is that significant, that 12 hours of interruption of temperature and humidity can affect an outcome, then you should absolutely be looking at redundancy.
Right. And so in my understanding, these spaces are not very forgiving. If there's a unit that goes down, Chris, what are we talking about? Like how long could a room survive with no AC? Let's say.
You better turn the lights out.
So, you better have a safety system that does it for you.
The plants.
Yeah. I mean, so when you have the lights on, you've got some significant heat. And so if we've actually seen scenarios where there were issues with power and things like that would trip variable frequency drive, shut down the equipment, and the rooms can skyrocket in temperature, and you got to have alarming to be able to deal with it. So, I mean, within 30 minutes to an hour, I think we were able to get the rooms nearly 100 degrees. I think we've got some trend data showing that shows, hey, the supply fan went out, the power, different phases, things like that, where lights can stay on, but at the same time, if they do stay on, you've got to start watching things like that. So, I mean, there's other specialty sequences you can put in there that says, all right, if I start to get too high, I better start backing some of the lights off if I don't have that redundancy. Because you also think about the grow cycle is the load every 6 days changes because you're now going for a different temperature. I mean, we'll see temperatures anywhere from 60 to 80 degrees, and we'll see humidity that is, and these are set points, as well as RH that they're going to want anywhere from 45 up to 65%. I mean, so you've got a very wide range of conditions you've got to go after, depending on, as in your words, Tony, the chef. They all have their own special secret sauce of what they believe does the best yield for them, what they're trying to accomplish. And so we go through that. So we actually just have Tom saying the hottest one he's seen was 117. So, I mean, there's a lot of different pieces that we deal with on these temperatures, but you have to watch. And once you start to get that hot, plants are not happy because of the fact that you'll start running out of moisture very quickly. They'll dry, wither. And you think about if you have $1 million worth of plant life in there and you killed it in a day, there went $1 million that you just lost, and you're trying to grow that room every 60 to 90 days. You're trying to turn it over complete, and that's $1 million costly mistake.
Well, I think the other thing, Chris, you were talking about, which I completely agree with, but these safeties should be in automation, right? And most of the ones that we've set up actually, and I know 100, and Tom, I did see where you put the 117 up. We don't let a room get over 85. I have yet to have a client ask for something to be that warm. So once we hit 85 degrees, if we're controlling the full environment, meaning the lighting as well, we start to reduce lighting at that point, and we're immediately notifying people, emails, text messages, there's an issue, get here. If we ever reach 90, we completely turn off.
Well, that's what Tom was saying. 117 is that's when the AC went down. It got up that quickly. And again, you think about if you walked away and didn't have notification, it does not take long to get there.
No. And once it's cooked, it's cooked.
Not only can it kill the plant, but I understand stressing the plant is very important not to stress the plant. Like even if it can go through something like that, it could still live and thrive, but then it's not quite the same product at the end of the day.
I think
that they
that
would have
goes
hoped
back
for.
to yield. You
Mhm.
opened up with that goes back to yield, right? Because not only quality but quantity, of the product. So,
Mhm.
and Chris, I think you'd agree over the past 5-6 years ago, we had a pretty broad tolerance of what we were allowed to do temperature and humidity wise, and I feel like every year it's getting a little tighter and a little tighter, and it's nice to see that, honestly, because anybody can control plus or minus 5 degrees, plus or minus 10%, right? But you want happy plants, right? You want happy products. You want to deliver the best quality for your customer. You're gonna have to find tighter tolerances, and
Yeah.
a lot of people are pushing towards it. I think they're understanding it more. And honestly, Tony, videos like this, I really think help to educate our growers and agriculturalists on exactly what they should be focusing on.
Absolutely. And like Tom was just saying again, and Tom, thanks for joining us. Also, Matt Warren, Courtney Sanders, thanks for joining us. And Alfredo had a great comment when we were talking about how hard it is. Then you throw in the geographical locations, like you're in a desert, one facility, and the other one's up in Michigan where you need, to provide cooling when it's minus 10 outside. So there's all kinds of different challenges in these facilities because they always need dehumidification and cooling. And so the other thing I was going to touch on, so the controls. Let's talk a little bit about controls. Difference between what we call configurable controls. There's a picture of a programmable one right there on the slideshow that's sliding. In programmable controls, how important is it? So, we sell all different types of equipment at Insight Partners, and some of them have configurable controllers, which are great for 95% of the applications. We have found in our experience, and I think most people who are grow room professionals have found that a programmable controller is super important in these types of facilities. Kirk, you want to touch on what that is and why that's important?
Well, I think the big thing is kind of like Alfredo there talking about geographical. Every build out's different, right? So configurable controllers are great for the markets that they fit in, for the areas they do. But when you have tighter tolerances, you have big swings. We've talked about going from day to night, but how that really impacts the room is it's an immediate shift. And you need controls that can give you a rapid response, right? So we have less stressing of the plants, right? More of a controlled environment. And so when you have a programmable controller, something you can write the custom controls sequence to, that you can get it to build its response time, and you can freely make those adjustments, not going in and making an adjustment here, making an adjustment there. But when you can go in and freely adjust PID loops, tolerances, you can automate and not quite AI, not yet, right? But you can automate set points and adjustment based on the room so that you get these rapid responses. That's what you get with programmable controllers. Unfortunately, configurable canned controllers just don't offer that type of flexibility, but you don't need that flexibility everywhere. But in this type of environment, you definitely do.
Yeah. Chris, anything to add on top of that? I mean, Kirk was so brilliant with his description. I'm sure there's nothing to add, but
it goes down to that flexibility, because you think about even canned controllers. If it's a configurable controller, it doesn't typically come with automatic call out and notification. You'd have to put some other supervisory station or something that says, I'm looking at that data, and then it does the call out to say, all right, if this room starts to get hot, who do I call? And so you still have to kind of layer controls even still to make sure that you do have that protection of what's going on.
Right. And that requires typically another company, another set of people, sometimes finger pointing. I know no one's ever had that happen but me on my jobs, right? So there's a little bit of finger pointing sometimes. So it's better to, and you get a perfect segue into my next question, was the response time, right? When there's a problem, how do we react to it? What are grow room owners looking for in response, right? Because I forget sometimes they're not in the HVAC business. They don't care about our equipment. They don't care about our controls. They wanted a certain temperature and relative humidity in the space, and they don't want to have to deal with it, right? If they never saw one of us their whole experience, they'd probably be fine with that. But what is the expectation of grow room owners in terms of, how the room's maintained and then how we respond when there's an issue?
I think what we're actually seeing is the opposite, though, is they don't want to see us, but they're starting to realize they didn't realize they needed to become humidity and temperature experts. They needed to get more involved. They need to get more engaged, and they're learning that through the process, because these are not set it and forget it. You have to be engaged. These are 24/7 operations if they're done well. And so the ones that are doing the best are the ones that have a more educated staff. This is not just a run-of-the-mill HVAC, because you think about one of the problems that we actually have within all HVAC industries is the cell phone. Why? Because everybody's now using this to be able to look at their home residential system, and they want to do the same thing for their grow house. Well, you can do it somewhat. You can get that remote capability. You can make those remote adjustments. But if something happens, you need somebody there, and sometimes you need them there quickly. I mean, we talked earlier about redundancy. If you don't have redundancy, you may not have an out. You may not have a solution to fix. And so you're having a crop that you can't do anything about. So when you think about the true critical nature, we have a lot where we've now started to see where they'll share rooms, where that day and night we talked about is that they'll have a unit per room, and then they'll have another unit that feeds both rooms. And it's the redundancy backup for that day and the night so that you can deal with that capability. And so you can minimize your cost for keeping that room in check, but at the same time, still having excess and additional capacity that you need to do it. So, I mean, one of the things that we always say in some of our classes is there's only one guarantee we make with mechanical equipment. It will fail at the most inopportune time. That is the only guarantee, because it's still made by people. Nothing lasts forever. And when you're putting it in harsh environments like we're talking about, it has a tendency to fail more often than you might like, but we still have to spend our time getting them to that point, making sure the owners are more educated. I mean, they're fantastic at understanding the grow process, but that grow process comes with other pieces. Now they've got to start understanding HVAC, temperature, humidity, CO2, demand control ventilation. Because you think about it's still demand control ventilation. It's just we're adding CO2 instead of taking it away because the plants demand CO2. So we're injecting CO2. We're doing things like that that are completely the opposite of what some of the other things. And they have to come into a lot of different aspects to truly run a full grow house properly.
So what I'm hearing is they need a partner, such as insight partners. Wink, wink. Right. So we do. So we are called insight partners. All fun aside, we do try to partner with our owners in our facilities because we do want, their health and maintenance of their business and their growth of their business. We want that to be part of that. And if you're watching this and you're not, you're looking, don't find just a vendor. Like, find someone who's in this business legit and is in this business to help you grow yours and become a partner. So Kirk, you've spent a lot of times on grow facility sites, right? I'm sure you've been there past 5 p.m. before a few times.
At least twice.
Past 5 a.m. too.
Past 5 a.m. And how many of the sites that we do are we remote monitoring or asked to remote monitor? Some of them might not want us to, right? Or do they all want us to? Or what are your thoughts on that?
So yeah, there's some people that we do a stint. We typically tell them we're going to provide it at least for a year. It's part of the cost associated with it. It's kind of I don't want to say it's a no option, but at the end of the day, it protects us, it protects our performance, and it ensures for them. I will say we're somewhere around 60-65% after the first year continue to utilize us, whether it's adding us to their VPN for a semi-restricted remote access, or if it's continuing through us with our cellular modems and how we do it. One of the biggest services that provides for them is you get a faster response time to viewing what the issue is, right? Hey, the machine's down, or hey, I have compressor 3 is not operating. We need to get somebody out here. And then, of course, we have these programmable controllers that you mentioned earlier. So we've had scenarios where a sensor went down and we were able to rewrite a code in a matter of 5 minutes without rolling a truck, get a system back in operation, back under control while somebody was coming out with the correct part, right? Being able to offer that type of response time with remote access and programmable controllers is really what the customers love and what they look for. And so they get that quick, we know what's going on service. And then they typically partner with us with their mechanical contractor so that when they're coming to site, we're there to provide support for them. So it's really kind of a team effort. And while we love it when we use our own service team, our geographical stretch for this is much larger than our service team can currently support. So they're getting there, but we do have service arms and there are service vendors that they have that we work with to take care of their customers, and we get calls at all hours, right? And they do consider themselves mission critical, so they really expect that top-notch support. And again, you've got $1 million sitting in a room, you get nervous if something's wrong.
Absolutely. And you brought up a good point that I didn't even think about earlier, which is when you have a custom grow room application specific controller, you can have a lot more diagnostics than you can on a controller that's configurable and not designed for that application. In other words, you can have current sensors all over the place, so you can see not only, we're calling for the compressor, but it's not coming on, right? So things like that, Chris. What are your thoughts on that?
Yeah, that's where you start to think about, we talk about, early on, we were thinking about the redundant piece of equipment. N+1, do we have a fully redundant equipment? Well, you also have to think about each unit internally to that unit. How do you build in some redundancy there? Do you have 2 compressors? Do you have 4 compressors? Things like that, because then you have multiple circuits. Because like Kirk was saying, hey, compressor number 3 is not working. We still have 75% of the capacity of that unit still operating, and we can dispatch a team to go out and fix it before it truly does become mission critical. So, you can upsize your equipment slightly if you have to, if you want to do it that's a less expensive way to get some level of redundancy built in, or you can go with the additional equipment as needed. So you can go a lot of different directions to be able to make sure that you have that capability to look at all the aspects and make sure things are properly functioning.
Awesome. Okay, 2 more quick things to hit on, and then we'll get you guys out of here. So walk through the process of, let's say it's a consultant and he's got his first grow room job. What do you recommend he does? Obviously, you want him to call us. And on that note, I'll put Kirk, Chris, and my contact information in the podcast notes, or if you're watching this on YouTube, I'll put it in the video description there. So you can contact us anytime. But if you're not going to contact us, what's the process they should go through in designing it right, making sure they got their building load right, picking the right equipment, controls, etc.? Kirk, you want to touch on that, or Chris? You guys, whoever wants to jump on that one.
Chris, you want to take this one?
Go ahead. Let's get you started, and then we'll close anything. Because the interesting thing is, as an engineer myself, my answer. It depends.
Everybody knows your answer. Yeah,
it
that's
depends.
right.
That's like different facets of what's going on here. And again, you have every different owner wants something a little bit different. So the most important thing is truly trying to get some understanding of the load, so you have the equipment that you need.
Yeah, so that was going to be my first comment, was you have to get the load right? So we need to know number of plants. We need to know watering rate. We need to know what type of lights you're going to have. All right. I personally love to know if you're doing hard on, hard off, or if you're doing a sunrise, sunset. But if you don't have that information, and then tiers. I'm not a drastic fan of tiers. I don't mind 2 tiers, but I have a few sites that have 5 tiers, and that terrifies me. Because it stratifies. The air stratifies as it goes through, and the more tiers you get, the more difficult, in my opinion, it becomes to get that consistent room. You start adding a ton more equipment, but I also understand that some people have more cubic footage than they have square footage they can work with. So, but that's the big thing to start with. And then the nasty part that I don't feel like enough people talk about, and I appreciate all the publicity that you give us, Tony, is you really have to talk about how things are controlled. Tom, I think you made a comment earlier about there was no safety for the lights in the original design. And you learn that lesson once it hit your wallet, once it becomes painful, right? You go, why didn't we have that before? You want to make sure you have an experienced contractor that, as you put it earlier, Tony, that has a resume with this, so that they've already learned the life lessons, right? And they can coach you through them. And adding something as simple as lights and safeties based on temperature is extremely easy to do, especially since you should already have a configurable controller on site. You need to add that sort of stuff, and that's where I would start. And I know it's a lot to start with, but if you don't get your load right and you don't know what you should be doing to the building in a safe manner, those are probably the 2 most critical things, in my opinion.
And the other piece of that is where, because we talked about it a little bit. Are you in the desert? Are you in a humid climate? Are you in the northern climates where it gets cold and you're trying to, in the middle of wintertime, it's -5 degrees, and you're trying to take return air, dehumidify it, and then heat it back up to keep the place warm? in the middle of wintertime when it's -5. So it's really dry outside. But you can't take advantage of that because you don't want to get rid of all your CO2. So each one of those applications changes the type of equipment, whether you're going to look at some of them that are going to be air cooled, whether you're going to look at fluid cooled, whether you're going to look at desiccants, all these different pieces, they all factor into that entire building. I mean, I even see the one talking about the architectural envelope. How well is the building built? I mean, some of these buildings were, when they were first starting out, okay, I'm putting it in the back room above a barn. And then you're going to start getting into something where I'm now a pre-manufactured building to go cheap. But now am I going to start looking at sealing the building? Because you think about what is HVAC in general? We want to control the temperature and humidity. We want to take it from someplace we don't want it and get rid of it to where we do want it. Well, if we're just taking humidity into a space from a plant or watering, we got to get rid of some of the moisture and just get it to go outside. Well, how do we do that? Well, we do it through condensate. We do it through all those different aspects, adsorption, things like that. I mean, there's a lot of different ways. And so the design challenges change in quadrants of the United States as well as at the same time as the type of equipment you might want to use. And you still have to make it so it's got that longevity. You want to make sure that it can handle your conditions. So it starts with the load, which changes by location. And you want to have something that is reliable as possible, knowing it's going to break when you don't want it to. And how fast can you get it back up and running? All those factors come into a long-term viable grow room project.
Excellent. Chris Adams, Kirk Patton, thank you so much. Excellent job as always. We appreciate you being on the show. We'll have to have another one. There's so many things I wrote down, like we didn't talk about airflow. We didn't talk about this. So we'll have to have another one. Talk about greenhouses. Thank you guys so much. I appreciate you.
Appreciate you, Tony. Thank you for putting this together.
Thanks all right, to all our folks that joined us today and looking at this in the future.
Awesome. Yeah, and thank you so much for joining us. The Engineers HVAC Podcast. I'm going to put a few QR codes up here to our YouTube channel, the podcast, and also our website, insightUSA.com. Also in the show notes of the video and the podcast, you'll have all of our email content. Just email us. You got questions, shoot us an email. We'll, if we can't help you, we'll tell you where to go. And we're glad to help you any way we can. So I'll put these QR codes. Thank you guys. If you can hang out for just a few minutes, and we'll talk in just a minute. Thank you all for watching.